Thank you very much. Well, let's get started after this very nice presentation. Yeah, I made a slide about us, but yeah, we have been already introduced, and just say that we are at Booking since a lot of time, and we work together also since 2 or 3 years now. But yeah, let's get started with this presentation. Here is the agenda of today's talk. So I will speak about the challenges that you might encounter when you evaluate LLMs. Then I will present a procedure about how to evaluate large language models. And then I will pass the mic to George, who will speak about the extra challenge that we will face when you need to evaluate AI agents, so LLMs plus tools. And he will also present the GenAI lifecycle of a GenAI product in Booking.com. OK, so let's get started with the challenges. OK, I have a very basic slide about, OK, what is an LLM, how it works. It will be very basic, but just to, let's say, to get us started. An LLM is an AI system designed to generate human language, basically. These models are huge. They are pre-trained on humongous amount of data, and they have a huge parameter space. It can be up to 100 billion parameters, so it's really massive. One of key point is also relevant for evaluation is the autoregressive nature of LLMs. So basically, they generate the next word, the next token, to be precise, based on the sequence of tokens that they have generated up to the step t-1. This is a nice image that I just created using chatgpt.com, but you can visualize the idea. So you have the input, the LLM generates, and then after the first 3 words, it generates the fourth, and so on. So despite this, let's say, rather simple way of generation, LLM showed remarkably good performance at several tasks that goes from summarization to translation, solving math problems, generate itinerary for a travel website, or things like this. OK, but then if LLMs are so good, why do we even bother to evaluate them? Well, there are some caveats. The first of all is the bias. So it is true that LLMs have been trained on very large data set, but maybe the distribution of your data is slightly different, or maybe it was underrepresented in the pre-training phase. So you cannot really expect exactly the same performance that you see on these shiny public benchmarks. Another problem is the notorious problem of hallucinations. So because of the autoregressive nature, the LLM do not possess really any internal knowledge. It just predicts the next token. So it can make up sentences which looks perfectly plausible, but they are actually false. And of course, you want to make sure that you keep this aspect under control when you expose this product, an LLM-based product to your customers. And then, of course, there is always the problem of cost. So because serving this model is not for free, it's actually very costly. So you want to, you want to design your application efficiently. Yeah, and this is the reason why we need a systematic procedure to evaluate LLM-based applications. OK, so this was the short intro. And then let's now deep dive in how we evaluate these objects. OK, the problem that we are facing is evaluating text, right? So this is nothing new. For example, in machine translation, they have a reference text, and basically they evaluate the quality of their model by basically measuring the similarity between the generation and the reference. With LLMs that can do many things, actually this is not a viable approach because basically of 2 problems. First of all, we often, I would say, almost always, we don't have labels. And then similarity is not enough, because 2 sentences might be very similar in structure, but semantically very different. OK, so how do we overcome this problem that basically we miss labels? Well, the solution is to ask human to annotate your data. OK, this is not very smart, and actually this is unfeasible. Especially if you want to evaluate LLM at scale, you really cannot do that. It's too costly, it's too time-consuming, so this doesn't work. Then what do? Well, we ask another LLM to evaluate our LLMs. Yeah, this might sound a little bit as cheating, but it is not. So we use another specialized LLM to judge the output of the LLM that is powering our application. Does this mean that we can completely remove the humans from the equation? Well, not really, but we can employ the human efficiently and only occasionally. The idea is borrowed, of course, by this paper, which was the first paper that mentioned this idea of having LLM as a judge. And actually, this approach is remarkably efficient. OK, so just to a nice visualization, this is the flow of developing a judge LLM. Our starting point, of course, is always the data. So we need to select a use case representative data set that contains our query and our LLM generation, but is missing label at this point. Then we ask humans to annotate this data. So in this case, then we have the human query, the LLM generation, and the label. For example, is this summary clear? Is this sentence factually correct? And so on. Once we have the label, basically we have what we call a golden data set. And based on this golden data set, we can prompt another LLM, which would be our judge LLM, to mimic the performance of the human. When we reach a nice performance in terms of, let's say, agreement between the judge LLM and the humans, it means that we have, let's say, a judge that is ready to be used in production. And then we can move, actually, does the pointer work? Yes, of course. We can move to the right, and then we can use our judge LLM in production to evaluate other LLM applications. Here I call them target LLM. And then, since we have the judge that can evaluate stuff and application, we can have nice reports that we can run, I don't know, periodically. Of course, being mindful of the cost, but this is essentially what we do. Yeah, so this is the idea. Of course, the key point in all this process, I think, is the quality of the annotation, because it's the thing that ensures that the judge LLM is performing as good as human experts. In order to ensure high annotation quality, we have a very strict annotation procedure that we follow every time that we want to create a new judge LLM. Again, we start with our data set, in this case without labels. And we spend time to create detailed metric definition. So of course, we talk with business experts, with persons that are developing a certain product, and we try to write down the requisite of the metric with examples and edge cases taken into account. And then we proceed to the pilot annotation. This is usually done internally. And only when we reach 100% consensus in this pilot annotation that, of course, involve only a subsample of the data set, then we start the real annotation process. We usually do externally with third-party companies, but sometimes we also do internally. And at the end, we got our golden data set with label. When the full annotation process is finished, we also have extra quality checks. So basically, again, we subsample from the full annotated set, and we make sure that the errors are below a certain percentage. Of course, if this is not the case, if the annotation doesn't pass the criteria, then we start the process again, because it means that we have to improve our metric definition and work basically the project from the start. OK. Yeah, in this slide, I inserted some tips about how to build a good judge LLM. Well, the procedure is not very different from traditional ML, but of course, there are some differences. We always recommend to, actually, this is a prerequisite to split your data between train and test. Then we usually use like most basic, or I would say most common base LLMs, and we prompt them to mimic the human performance. And then if we test if the performance is good on the validation, and then on the test set. As a tip, we suggest to start with a relatively large LLM, because in this way you can set some some threshold about, no, not more of an upper bound of the performance that you can reach. Of course, even if the performance of the judge looks quite good, we always suggest to do a thorough error analysis in order to, let's say, avoid basic mistakes that LLM can do. Yeah, and this is it essentially. This is the procedure that allows us to monitor our LLM in production. This is a slide with an example of a dashboard that we have for one of our LLM-based applications. As you can see, we can monitor multiple metrics at once. We do it every day, of course, because of course we do it on a subsample of the data, and then we can test various aspects of our LLM. So we can monitor if the user is frustrated. Hopefully, we try to keep it low, but we can see spikes. By the way, this is just an example. And yeah, we can, as I said, we can monitor various aspects of that the LLM application is doing. OK, so this is the procedure. It's nice and compact. It's actually nothing difficult. The most important things, as usual, is the annotation, as I said. Of course, there are some bottlenecks, but we also have a way to kind of remove them and speed up the process. Prompt engineering, as you might know, is a very tedious process, but there are several LLM-based ways to optimize your prompt. For example, there is a nice one for OpenAI. We also have an internal project to optimize prompt engineering based on LLM. This is very effective, and it's especially very effective when you have very precise annotation guidelines, because you can reuse them to optimize your prompt automatically. The annotation is also a very lengthy and tedious step, but LLM can help also there, because you can, for example, you can employ a jury of LLM to annotate your data, and then you can focus only on the examples where the combination of LLMs disagrees, so you can focus your annotation on the difficult example rather than wasting time on trivial examples. When you have a problem of cost, because maybe your judge LLM uses a very big base model, you can use knowledge distillation and, for example, fine-tune a smaller model to optimize on cost and latency. Yeah, this is the idea of the judge LLM, the powers of our evaluation, and is also an important ingredient of agentic evaluation. Let's briefly mention the impact that this approach had in booking. Of course, there is a massive cost saving, because human annotation can cost up to $1 per single sentence of annotation, while you can reach the same, basically you can have the same thing, or more or less the same thing with an LLM that can be order of magnitude cheaper. Some of our judge uses GPT-4o Mini, which is a factor more than 3,000 cheaper, so it's a massive cost saving. But even more important than the cost saving, I think, is the ability, we unblock the ability to evaluate LLM-based application at scale, because it would be impossible without the use of LLMs, because the human annotation is just a too lengthy process to be used. And the performance is actually very good. We have judge LLMs that are more or less almost on par with our human annotators. OK, this was it about the idea of judge LLM. Now George will talk about how you expand it to agents and what has to be done.
Nice. Thanks, Antonio. Hi, everyone. I'm George. And this part of the talk, we'll talk about how we can evaluate agents. And specifically, I will go through a series of metrics that we can use to evaluate agents. But first, let's make sure we are all on the same page when we talk about agents. So what are agents? In Yao's paper, Tao Benz, they define agents as systems that do the following. They can interact seamlessly, both with humans and APIs. They can incrementally gather information and resolve intents. They can adhere to complex policies and maintain consistency and reliability at scale. So this is a large set of requirements, which means that, in general, agents are complex systems. and much more complex than the single LLMs that Antonio talked about. Let's look at some pros and cons between agents and LLMs. Agents in general are much more flexible and autonomous systems, and the key advantage of agents is that you don't really need to specify your workflow. You don't need to specify the steps of the workflow because the agent can do that. On the negative side, though, they are much more costly, they have much bigger latency, and usually you need a quite powerful LLM because you need a good LLM to coordinate the flow of thoughts and actions. Also, many times you need multiple calls, exactly because the agent does by itself multiple steps, which means that also the chances for hallucination are larger. This autonomy makes agents more error-prone and harder to debug. So in short, we see that agents have extra flexibility and autonomy, but because they are more complex, they demand for more complex evaluation. So let's see how we can evaluate them. The first type of evaluation we'll talk about is called black box evaluation. And we call it like that because we treat the agent as a black box, and the only thing we care about is what comes in and what goes out. The first metric that we will describe, and possibly the most important because it correlates the most with business metrics, is called task completion and is defined as follows. So given a task definition, for example, generate an itinerary, a user query like plan me an itinerary for 7 days in Slovenia, and some constraints to satisfy, like what's the country, what's the how many days, and what is the budget. We want to evaluate, based on the response of the agent, if it completed the task, satisfying these constraints. So let's see how we could design a system that does that. So let's suppose that we have an agentic system. It can be multi-agent or not. We have a user that interacts with this system. And we have an application configuration where we define the specs of the agent and also business constraints, like some constraints from the business about what this agent should do. If we have this, and we have access to all the data there, we can have an LLM do extraction of the components that we need to evaluate task completion. So from the interaction of the user with the agent, we can extract the user constraints. From the application configuration, we can extract the business constraints. We can also extract the tasks and the responses. And if we have all that, then we can have a judge LLM built in the way that Antonio showed to evaluate whether the task is completed or not based on these components. Of course, we should not rely solely on this judge LLM. So it's good to have also another judge for factual accuracy or hallucinations. And most importantly, if possible, we should have user feedback, because this is the best proxy on whether the task is completed or not. If we have all that, then we can create an evaluation report where we can know for each query whether the task is completed or not. This metric, though, has several challenges. So one of the challenges is to define whether the task is completed or not. So let's consider an extreme scenario where a user asks the LLM, help me plan my summer vacation. And the LLM says, go to Greece. While in theory, this could be a valid itinerary, we don't really want for this task to be assessed as completed. So it's super important that we define very clearly when the task is completed, and it's not very easy. Also, users during the interaction might have multiple requests. So there might be more than one tasks. And finally, when we have a new system, we don't really have data, which is the common cold start problem. So let's see some solutions about those. For the task definition, one thing we can do, if we cannot get a definition from the business stakeholders, is that we can extract the task from the base agent prompt. Because usually, the model builder, when they write the prompt of the agent, they usually define there clearly what is exactly the task that the agent should do. So we can extract it from there. For a conversation that have multiple tasks, we can have an LLM extract all the tasks from the conversation, but we need to make sure that this LLM is evaluated and is of high quality. And for the new systems, we can employ synthetic data generation techniques, which we can do either manually if we want to create a small data set, or automatically with the assistance of an LLM. Now, the next metric is consistency. And from systems, we usually want them to be reliable, which means that if we pass similar inputs, we want to get the same outputs. So as an example, if we have like a property recommendation LLM, and we ask, recommend me hotels in Madrid, or give me ideas for accommodation in the capital of Spain, we want to get the same responses, because the question is essentially the same. So one way to evaluate this is to run the agent through multiple queries that are similar and evaluate the average success rate. Another way, which is defined in Yao's paper Tau Benz, is a metric that's called pass hat k. And it says, what is the chance that all k trials are successful? So we run multiple similar queries, and we check what is the chance that all of them are successful. In this paper, they run experiments to compute this metric for many state-of-the-art at the time models, and they compute what is the pass hat k. And spoiler alert, the results are not really great. So in this chart, you see several good models, and you see that as the number of trials increases, the chance that all of them succeed goes almost to 0. So if the number of trials goes more than 32, this goes almost to 0. So this means that consistency is a very real problem in today's agents and in general LLMs. So you should always make sure to monitor and make sure that it's not that bad. The next metric is about, it's actually a series of metrics that I like to call the decision-making triad, because it's about the metrics that we want to evaluate before we deploy our agent. And those are the performance with judge LLMs, as Antonio showed, the total cost of the agent for the whole trajectory, and the total latency. So what we do recommend is that every time that you're thinking about deploying an agent, always test against an LLM baseline and compute this metric. So make a table, compute both for your agent and for the LLM these metrics, and make an informed decision on whether the improvement in performance justifies the extra cost and latency from the agent, because that will help you make much better decisions. The next part of the evaluation is white box evaluation, and we call it like that because now we look at the internals of the agent. The first metric is called tool proficiency, and it answers the question on whether the agent calls the right tools and in the right way. In order to answer the question of whether it calls the right tools, we have a metric called tool choice correctness. And to check whether it calls them in the right way, we have a metric called tool call validity. So let's start with that one. So this metric consists of a series of checks that assess whether tool call is valid. And it's inspired from the Berkeley function calling leaderboard, which is a benchmark that assesses how well LLMs deal with tools. So basically, for this check to work, you provide a tool call, and you provide also the list of available tools. And then it checks, is the name correct? Are all the parameters, the required parameters there? Is there any parameter hallucination? Are the parameter types correct? And lastly, do the values of the parameters follow the specified format? So if all of these checks are correct, the metric returns that the tool call is valid. If not, it returns the error from the first check that failed. The next metric basically says whether the agent uses the expected tools to solve the task. So we need to pass a set of expected tools that we expect the agent to use in order to solve the task. And we need to either provide it manually or via synthetic data generation with an LLM. We provide the list of available tools and the answerable tasks. And we check what tools the agent used in order to solve these tasks. And basically, the check boils down on, did the agent use the tools that we expected to use? If it did, then this metric returns correct tool call. Otherwise, it throws an error. Now, the last tool-related metric is about the reliability of the tools. And usually, tools are registered in a centralized tool repository. And when we are using tools, we need to be confident that these tools are defined clearly, and most importantly, that they work as expected. So ideally, we want each tool to have a reasonable latency and failure rate. Ideally, it should have service-level agreements defined and monitored. And also, each tool needs to have a correct and standardized signature, which means clear naming, clear description, and correct argument types. It's important to note here that this metric is independent of the agent under evaluation. And it's applied by itself on the tool repository. So it's completely separate from the agent. Now, if you want to actually use some to do evaluation of agents, two nice frameworks, open source frameworks, are deep-eval and agent-evals that together have a large amount of, they cover a large amount of metrics from the ones that we mentioned, but not all of them. However, this space is expanding like every day, so I would recommend, if you really want to use a framework for agentic evaluation, to do some research, because probably by the time there might be better frameworks or more features on them. Now, because we don't have a lot of time, there are some more aspects that I'm not able to deep dive, but I would really like to briefly mention. One of them is trajectory optimality. And basically here we can check, does the agent take the optimal actions in order to solve the task? Here the real challenge is to define what is the optimal set of actions. Agents also reason, and one thing that we need to be able to evaluate is the reasoning capabilities of the agent. And one way to do that is to check how fast does the performance degrade as the task complexity increases. We will expect that an agent with good reasoning abilities, the performance would degrade much slower as we increase the task complexity. Another aspect is about long-term memory. So when we generate memories, we need to ensure that they are factually accurate, correct, and relevant. And last but not least, we have safety and compliance considerations. So we have metrics like bias and discrimination, and we have activities like red teaming. Now, in the last part of this talk, I want to talk a bit more on a higher level, how we recommend for you to see the evaluation within the GenAI lifecycle. A typical lifecycle, of course, a very oversimplified one, when evaluation is not really a core part of it, is like the following. Usually, you have like a model builder that tunes a prompt, usually manually on a small data set, and where they are fine with it, they do some basic evaluation, usually by eyeballing and on a relatively small data set because it's manual. Ideally, in the end, they run an A/B test to evaluate the effectiveness of the system. However, we recommend for the evaluation to be a core part of the development lifecycle, which means that we do suggest that you should specify the evaluation criteria even before you start working on the LLM. And when you specify those, you can then develop scalable evaluators, like using judge LLMs, as Adonio said. And the nice thing is that if you now have evaluators that you can use to evaluate the outputs of your LLM, you can actually now do automatic prompt optimization and on a much larger data set, which eventually will give you much better results and without having to do this tedious prompt tuning manually. Before the A/B experiment, we suggest to do standardized evaluation on key metrics, for example, hallucinations, and on much larger data sets in order for them to be representative. Finally, after the A/B experiment, we suggest to continuously monitor the performance of the agent using judge LLMs and set alerts. In this way, if there is going to be an issue in production, you are going to be notified, and then you can trigger error analysis to fix the issue. We always recommend to keep a human in the loop because LLMs make mistakes, and especially if the pipeline is very important, it's good to have someone to do a sanity check. Now let's finish with some key takeaways. Sorry. In this talk, we talk about how we can use judge LLMs to scale GenAI evaluation. In the process of building judge LLMs, the most important part is the creation of a high-quality golden data set, because that's the key element. We said about the agents that are more complex and require additional evaluation. And in this talk, we talked about task completion, consistency, latency and cost, tool proficiency, and tool reliability. And finally, we suggest to treat evaluation as a first-class citizen, because this is the way to scale trust of GenAI applications. Thanks a lot, and happy to take any questions.
Thank you, George and Antonio. We have time for 1 or 2 questions.
Yeah, I have a question. Like, how do we break the cycle of having LLMs as judges? Because you have an LLM as a judge, and then you can have an LLM as a judge that judges the judge, and this can continue for forever. And the other question was, when we generate synthetic data, it's the same problem. We're using an LLM to generate our synthetic data. How do we validate that synthetic data? Like, for example, finding the optimal path. Like, let's say we generate an optimal path, and then we validate that optimal path. How do we validate that the optimal path that the LLM provided is correct?
Yeah, so you don't really need to have judge LLMs to evaluate judge LLMs, because the key idea with these golden data sets is that basically what you want to do with the judge LLMs is to mimic human behavior. So this is why we say it's super important that your golden data set really has clean annotations. And if you have that, then you can know, based on how much the judge LLM performs, that it's solid. It's also very important that this updates over time so that it's not static. But in the end of the day, if you have a judge LLM that you know reliably performs good in this golden data set that mimics basically what you want to achieve, you can be confident that at least it will perform well. And same for the synthetic data generation.
You have one more question.
All right, thank you for this nice presentation. Really enjoyed it. So I'm curious about the golden data set. It's not super cheap to generate it, especially if you have human annotation. And so I guess you don't do that for every use case you have. And could you give some examples of use cases that are relevant enough to go through this process for you?
No, we do it for every use case. Like, we might not do it if we have a golden data set and another use case is very similar, so we can do some sanity checks to see if it's correct. Expensive is subjective, right? Like, it takes time, so you can have someone do it. I mean, minimally, you can do it for like 100 or 200. Like, you can sit for 1 or 2 hours and do it. It's not that hard, and you can actually have 2 friends over pizzas and do it to have like a good agreement. But no, we do recommend to do it always. Otherwise, you are basically blind. Like, you don't really know how well it correlates with your judgment.
All right, that concludes this talk. If you have any further questions, you can find George and Antonio right next to the stage. Please, one more round of applause.